Hi there, students. This classwork is on a little bit difficult geometry, the shape of an object. Well, in AutoCAD, using the two-dimensional facilities of AutoCAD, say that need to draw the projection of an object. Well, it has some entities, okay, for which there is only one tangent point. Well, remember, in the record, well, on the problems and their solutions, well, I already highlighted that if you need to draw a circle to have the projection of an entity, okay, it has only one tangent point. In this example, you see this circle arc is the requirement and it has only one tangent point. There is one more point, but that point is not tangent point. It is a point to have along the circle after drawing it. In other words, the circle at the creation stage must pass through such a point. Well, how we can find the center of the demanded one? Well, if you selected classical drawing method, then sure, without drawing the construction lines, okay, if the problem is this type or case is like this, then about point P without drawing a circle in the size of the demanded one, and say without drawing a parallel line with respect to the available at a distance, that distance must be equal to the size of the demanded one, cannot find the center. I already make such highlightings. In other case, here we have a circle. It has been already drafted, and there is similarly a point, and this arc is the demand. Okay, be able to find it the center. How? Without drawing this, without drawing that, those construction lines cannot find the center. If, of course, the method is the classical method. Okay. Well, in Metro class, you know, in the content of this week, can find the already recorded audio-visual video films. Some of them are on the theory, problems and their solution methods. The others just illustrate the things to do in CAD environment. Okay, well, here the other one, worksheets folder. Open the worksheets folder, clicking on this hyperlink, and then from the listed one, just the worksheets, select worksheets number 3, worksheet number 3, and then for each projection shown on worksheets, well, I recommend study on that projection, applying the classical method using 2D facilities of AutoCAD. Okay, study on the projection one more time, applying modern method. And then, using the three-dimensional model creation tools of AutoCAD. Yes, a few years we have the 3D tools in AutoCAD environment, you know. Be able to create the solid model of the object in AutoCAD. And then, yes, in the scenario, there is an AutoCAD file. It is two-dimensional, the projection of something. But today, we need to have it as model. Create the model of it. Of course, for model creation purpose, not AutoCAD, but new generation software, such as Autodesk Inventor is recommended. You know, Metu NCC, Autodesk products are used in drafting design courses. So, export AutoCAD file to Inventor and then create the model of the object. Yes, this item is about such an exercise. And then, the other scenario, in item E, as it is mentioned, imagine that there is no AutoCAD file in the memory of your computer or in the archive of the company in professional life to import it to Inventor, can do what? Use the tools of Inventor, starting from sketching stage in sketch environment, using the tools, be able to draw the necessary sketch, and then using that sketch as the profile, close profile, followingly apply model creation processes. As for each projection, if you have time, especially by selecting the difficult ones to their geometries, I recommend pass through such stages and study on those for being more ready to take the main exams and also to take a responsibility in professional life after graduating on design and manufacturing part. Okay, well, the worksheet 10. With a click, open that worksheet how by downloading. I downloaded that worksheet, and then here it is the content. On the worksheet, well, there are 1, 2, 3, 4 different objects. Well, we have their pictorial views, like as if photograph, and one side view. That is the object. It's a simple right prism with rounded edges, and that's its front view. We have such an object. Okay, it is a composite prism. At this side, there is a boss. At the opposite side, there are two bosses. Okay, the boss at the back side, this one is hidden, the other one also hidden. But here on the projection, relative to the observer, he or she observes the body in the direction my cursor is moving along the ray of sight, okay, sent by the observer, say in this direction. The frontal boss, since it is in the same size that of the backside boss, well, we have the projection of visible boss, and it is coinciding with the image of the hidden boss. But here at the frontal side, there is no extension, so we see the boss, okay, how it is hidden. So, well, here on the projection, we have its image under the common agreement, in accordance with the agreement, you know, in engineering drawing. Well, if an entity is hidden with respect to observer, it is behind of a certain obstacle, then drawing the projection of such an entity, we use dashed lines. Yes, that is the reason why here we have a dashed circle. Of course, this part of the, well, make zoom in. Okay, much more easily see. You see, after this tangent point, from here to the next tangent point, this part is visible because it is the projection of that tangent cylindrical surface. It is an outer feature, so it cannot be hidden. Okay, then, well, on this geometry, since I already focused the attention little bit in detail to this geometry, then I think you understood. I'm going to select this one, okay, in this classwork and study on this projection twice. But in this classwork, applying classical method, next classwork, applying modern method. And then, well, one more time, I may demonstrate how the model is created. Okay, it may be a different video record. Here, see, we have some tangent lines, but some of them has only one tangent point. For instance, this one, you see a circle arc. It is tangent to this, tangent to that. It has two tangent points. And we know it is radius. So for this boundary, there is no difficulty. If you selected classical method, select 10 radius option from the list. The listed ones are the tools for creating a circle. And then, well, indicate the entities to those the arc circle must be tangent, and then write the radius and input. But cannot say similar things, same things for this circle arc. You see, this circle arc has only one tangent point. The other point is not tangent. Well, I think you perceive that this boundary to its characteristics, okay, just matching to this construction case. There is a circle, there is a point, and the demanded one, okay, the one to draft at this stage is to be tangent to the available one and pass through point P. Yes, obvious that here it is in the same characteristics. It has tangent point, but it has only one tangent point, and the other point is just it is terminal point. How the center point of this circle arc can be determined without drawing the construction lines? Impossible. Which construction lines? Well, about point construction circle, its size must be equal to r. About the center of the available one, in other construction circle, its size must be equal to r plus r1. R is the radius of the demanded one, r1 is the radius of the available one. Of course, this coordinate r1, r plus r, in other words, it is the coordinate of the center of the demanded one, but it is just the radius of the construction circle to create. You know, this construction circle is the locus of all the points being such a millimeters away from the center of the available one. One of them is the center of the demanded one. It is the locus, you know. If the center of the available one is at the outside, yes, that is the coordinate. But if it is, if it were at the inside, the center of the available one were not here but there in the region bounded by the demanded circle, then this coordinate value, so correspondingly radius of the construction circle, will be equal to r minus r1. Well, remember, well, here it is a similar case. Center of the available one is within the area, so coordinate is r minus r1. R is the radius of the demanded one, r1 is the radius of the available one. Yes, already studied on such construction cases, okay, previously. So, well, here, time to apply this learning outcome. Okay, then. Well, I'm going to take a screenshot. You know why? To have the projection on which gonna study in AutoCAD environment, as if, well, as the hardware were two different displays. So clicked on print screen button, take the screenshot, and then, well, write the name of the famous software, Paint, into the search box, and then, well, program operation system will find its address and bring the hyperlink to the list. Clicked on this, and in Paint program, clicked on paste button. And then, well, since gonna study on not the others but this part only, yes, crop the rest. And then save this file in the memory. Okay, save as. Well, sure, if a file is saved in Paint environment, then it is going to be a picture file. Okay, show the address. I'm going to keep the data in this folder, that subfolder, this nested folder, and the name. It is from WS worksheet 10, and it is, you see, for which it is written projection 6. Okay, I'm going to use this acronym VU, V, lowercase v, 6. Okay, I use this identification. Okay, then, well, can close Paint, can close this, well, worksheet file. And then, well, in AutoCAD. First, study on that projection applying classical method. This is my template file. I pen the paper simulation to one of the sites, and then in the memory of the computer find the picture file. Just I save it in the address and then say copy paste. You know this. Okay, lots of files. These are all the subjected things from the beginning of the semester. Okay, and here is the newly saved screenshot. Right click the mouse and say copy, and then in AutoCAD you see I have an empty space. I'm going to paste that screenshot over here, and as if there were two monitors conveniently study on the drawing. Okay, I'm going to paste that screenshot in one of the layers. Which one? I drop the list of the layers, and then why not select construction layer, and then click on paste button. The simulated one is the frame of that screenshot. Click and press enter key twice. Okay, after the anchoring stage, if still you have empty space, make a click at the corner, hold this gripping point and drag the mouse. It is to make the screenshot larger. For your convenience, make it in a suitable size. And then yes, the method is classical method. In the classical method, you know, start from that stage. If there are some center points to mark, okay, or the points to mark, mark them using transfer lines. Okay, transfer line method is my favorite method. Okay, there are 2 points to mark at the first stage. Then followingly create the corresponding circles, this point and that point. Okay, marking the first point, well, arbitrarily show its location with a click, but marking the other, you know, in classical method we use this facility, parallel with full distance facility. It is for measuring distances and to have the necessary transfer lines. Okay, at the intersection of transfer lines, you know, we obtain the projections of the characteristic points. Okay, then start. Drop this list and select for marking the first point cross option, and then, well, I'm going to show this point, okay, as the location for this center point. Do not think too much. If cannot find the projection in the end at the center of drawing area, working area, then I can cut and paste the projection, you know this. So, well, mark the point, making a click over here. Press escape button. Yes, these 2 transfer lines intersecting each other here, and in my consideration that point is the center of this group. Okay, and then the center of the other, yes, I said previous delivery 2 center points, but here one more time careful looking at, I see that there is one more center here. Okay, to mark, it is the center of this circle arc. Well, since we know it is coordinates and we know it is size, so, well, at the beginning, okay, mark the center of it and then create the necessary circle in the end to have this tangent circle arc. It is a circle arc, you know, but we don't know where is the starting point of the arc, where is the ending point. You only know that ending and starting points are tangent points. At that point it is tangent to the following, it is tangent to the preceding arcs, the other arcs. Since at the creation stage for such circle arcs cannot know where is the tangent points, you know, the only thing to do is that imagine the circle arc as if it a full circle created, and after creating the other tangent entities, then applying trimming, delete the rest. Yes. And on this geometry, well, I said that here this part requires two construction lines. And well, one more thing, remember 2 weeks ago talking about how a piece of line can be created, straight line can be created. Well, as one of the cases, I focused the attention to such a thing. The straight line is to be created as being tangent to a circle. It has only one tangent point. Then, well, in classical method, for instance, this line has only one tangent point. We know it is inclination angle, okay? We know that it must be tangent. The length not so important, may be known, may be given, or it may be unknown. If it is given, then create the line, writing it is order of magnitude at the creation stage. If the length of the line is not available, then create it, say, as longer than it is order of magnitude. Have further extension, and via trimming can set it as size followingly. Yes, you know such techniques. Creating such a line in classical method, there are 4 tricks to know. Well, studying on this more difficult example, I'm going to remind you how such a line can be created, and one more time demonstrate how such a circle arc can be created. But here, well, after marking the first point using this cross, then I should mark the others. Well, the center of this second group, where we have 2 concentric circles, 10 millimeters, 10 units away with respect to here in the down direction, and then have a look at in the horizontal direction 30 plus 55 units away. So these are linear distances between the center points. Well, in classical method, we measure input the linear distances, horizontal, vertical distances, you know, using parallel with full distance facility. No need to change the layers because, well, all of such tools, there is only one layer. It is the transfer layer. It is a system layer. That layer is automatically selected by the software, and the output of the process will be created in the content of such a layer. You know this. Clicked on parallel with full distance option, and then I know that the center of this 10 units away in the vertical direction. Indicate this transfer line. It passes through the center of the first group. That point is the reference, so the transfer line passing to that point is the reference line for the other. Okay, indicate this as the reference, and into the box after the click it is added to the train. Second box, write the distance, offset distance 10. Press enter, and then I know that from the given projection, available projection, the center of the second group is at a lower level. So move the cursor in the down direction and click. That is it. This is the transfer line. I'm sure center point of this group is along this line. Where indicate this vertical transfer line as the reference, and into the box write 30 plus 55, 85 units away. Press enter, and that point is at the right hand side relative to the first point. Move the cursor to the right and then click. And then yes, that is the center point of for the second group. And then center point of the other one, well, say the center of the circle arc and the center of these 2 circles are in alignment in the vertical direction. Both of them use the same transfer line. But the center point, the third center point, is 25 plus 25. Okay? Yes, see, relative to the center point, the location of the center is 25 plus 25, 50 units away. Okay, then I know that this is the transfer line. It passes through the first point, indicated as the reference, and then into the box write 50. Press enter and then move the cursor in down direction and click. Yes, that is it. This is the end of the center point marking stage. The end of the first stage, so why not say that time to save the file. Saving time. Save as. Address, check whether it is the correct address, and then write the name of the file. Surname, ID number, okay, if exits write section number, and then this is an example from worksheet 10, WS10. Well, the selected projection has been identified on the worksheet saying View6, V6, and which method I selected and already started to apply. Classical method, write this word, classical, and date of this studying is 17th of April, April 17. Okay, and then continue. In classical method, after marking the centers of the circles, which their dimensions available, and we know where they are, create the axis of symmetries. If there is a full circle or semicircle, full ellipse or semi-ellipse, then symmetry axes are needed, you know. Well, use this facility, center line cross. Well, I'm sure this point is the center of the first group. What you see, my purpose is to snap, indicate intersection point, but the highlighted symbol is midpoint symbol. Well, if midpoints, software has been enabled to indicate midpoints. Midpoints aggressively attract the cursor. So, well, I don't want to mark or indicate a midpoint. So, from this enabling list, I'm going to deselect midpoint option and disable software from snapping my cursor. Okay, and then indicate this point. Now the highlighted green cross to say that there is an intersection. Yes, it is the correct intersection. It is the center of the first group. After seeing this highlighting, click your mouse. And then I said that it is the center of the circle. And computer asking me, software asking me, okay, then the arcs, symmetry axis, symmetry axis are ready to be created, about to be created, but for which circle? If over there there are concentric circles, write the outmost, the size of the outmost circle. Here the diameter of the outer circle here in this group is 40. You see this number is over there, 40, diameter symbol. Write 40, press enter. I am sure, well, I have now the axis of symmetries in the correct size over there. Start the process clicking on the button, and then, well, I know that this point is the center of the second group, indicated as the center. Diameter, well, here this number you see is the same, 40. Write 40. Okay, to have the axis not only for the outer circle but also inner circle. Partially the axis of symmetries will be the axis of symmetry of the inner one. These are concentric. Shall we create the axis of symmetry for this part? At the stage, following stage, although over there will be a full circle, but after trimming it is going to be a circle arc. Not semicircle, not full circle. So here, over there is no symmetry axis to show. Okay. If it were full circle or semicircle, then I would say yes, create the axis of symmetries, but here no. Just have it as center point thanks to the existence of the intersecting transfer lines. Okay, then create the circles at the following stage. Okay, third stage, save the file at the end of each stage. I recommend, it is recommended. And then time to create the circles. Well, I see this circle visible, but that one is hidden. But here about this point, remember, similar the one on which already studied, selecting, I remember, I think it is worksheet 7 or 6, I'm not so sure. Studying on the example on one of the worksheets, yes, we already dealt with a similar case. Well, there is a piece of visible circle arc to have here, but that stage we don't know where is the tangent point, where is the ending point, starting point for this circle arc. So the thing to do is that create it as if it were a full circle. So about this point at the circle creation stage, we have 3 circles, 2 of them visible, 1 of them hidden. Okay, I selected visible 1 layer to have the projection of visible entities. Here is the model of the object, photograph of the object. Okay, I see which entities are visible, which ones are hidden. Okay, and then, well, create the circles. If you know the diameter, center diameter. If you know the radius, selecting center radius option. Center diameter, well, this is the center point. Okay, inner circle is of 20. Yes. Okay, restart the process, indicate the same point. The outer one is 40. Okay, about this center point there is 1 more circle. I'm going to create it after creating the other visible ones, because I need to change the layer. Before changing the layer, says since I know that about this point there are 2 visible circles, about this point there is a visible, say, full circle to draw. So, well, continue. I clicked on diameter option and then indicated this point as the center. The inner one 20, reclicked, outer one size is 40. Okay, well, for this arc I know radius. You see R means radius, it is 10. If you want, yes, multiply 10 by 2 and then selecting diameter option, create. Or just instead of multiplying the radius by 2 and thinking about such an arithmetics, select center radius option and then indicate this intersection as the center and write the radius, it is 10. Yes, that is these are at the stage to create the visible circles. And then without forgetting, change the layer. Okay, select hidden layer, hidden 1, hidden 2, select one of them, and in that layer create a circle, selecting diameter option. Well, for that hidden circle, you see the center is the first point, center point, and the diameter is 40. Yes, hidden and visible circles are coinciding. But after trimming the unnecessary part of the visible circle, then gonna have the hidden circle arc over there. Okay, save the file and then the rest. Well, the lines, the other lines. Well, here there is an easy cake to deal. Yes, you see this circle arc. There are we have 2 tangent points, and we know it is radius. Classical method, you know, for creating such a circle arc, using 1010 radius tool of the software, can first create a full circle and then trim the further extensions. Yes, no need to draw any construction line. If for a circle to create there are 2 tangent points and you know it is radius, no need to draw any construction line, because we have a sub-program in the structure of AutoCAD, and it is push button. Here is the push button, 10 radius. I started the process, and then from the projection I know that the tangent point along this circle is expected at it is 1, 2, 3, third quadrant. So at the indication stage it is important which quadrant of the available circle do you expect the tangent point, and then answer this question and show the circle it is that quadrant. Move the cursor to the vicinity of the available one at it is third quadrant, because tangent point is expected over there. Okay. Snap configuration is automatic in using 10 radius facility. Just indicate the circle after seeing the highlighted tangency symbol. And the other tangent point is expected at the second quadrant of this circle. So indicate the circle, not this quadrant, not that quadrant, at the quadrant where gonna have the tangent point. And then write the radius 10. That is it. I made a mistake. I forgot to change the layer. So I created the circle in the wrong layer on the wrong page. Instead of saying oops and creating, I'm going to use the other technique. I selected that line. I by mistake created it in the wrong layer, and then dropping the list of the names of the layers, show the correct address. The correct layer, okay, to select for creating the circle arc, I know that visible one. Bring the cursor onto the name of that layer and then make a click. That's it. Okay, method is classical method. Do not need to carry the further extensions to the last stage, okay, because otherwise they may make the region crowded unnecessarily. In classical method, trimming is applicable at any stage. Okay, there is no risk. I'm going to start trimming process, and while still keeping the relation between this and the others, I'm going to trim the unnecessary part. Yes, via indicating. Here you see I managed to have this part of the projection. Press escape button. And similarly here there is one more circle arc. It has two tangent points, tangent to this circle, tangent to that circle. I know it is radius. Okay, start TTR process and then indicate. It is tangent point is expected at the first quadrant of this, the fourth quadrant of the other. I indicated the available circles accordingly, and then radius is 40. Yeah, I made the same mistake. I forgot again to change the layer. So shoot it to the visible layer. And now, for creating having the others, now I know that visible layer is the correct layer for the others. Okay, I selected. Trimming stage, yes, trim. Apply trimming process. Instead of indicating 1, 2, 3, 4, 5 segments, I'm going to use my technique. Trim the first segment, trim the last segment, press escape button and delete the rest. Yes. Yes. Here I might also trim the further extension of this circle. Why not restart the trimming process and do it? Yes, after creating the tangent lines, I know where is tangent point and which part is further extension. Okay. One more circle arc here in the same characteristic. It is an easy cake. It has two tangent points. Created 10 radius. And then, it is radius is 95, and I know that it is tangent to that circle at it is second quadrant, tangent to this circle at it is first quadrant, and the radius 95. Here is the circle, and then trimming stage. Press enter, trim the first segment, trim. It is last segment, and then the rest. I like this technique. If along the further extension there are lots of intersections, so lots of segments to indicate, well, trim the first and the last segments, and then for deleting the rest, select it and press delete button. Okay, great. Save the file. And then yes, here, more difficult features to deal. Well, this tangent line is difficult, more difficult in classical method, in applying classical method to create, as I already informed you, because it has only one tangent point, and to be able to create such a tangent line, okay, in classical method, we should know 4 tricks. Okay, the first trick is the same trick, not a matter the tangent line has only one tangent point, it is, or 2 tangent points. What is that? Start the line drawing process. After starting the line drawing process, change the snap configuration. Enable software to indicate tangent points only. It is the first trick. You should know. Start the line drawing process. Yes, and then the first trick. Bring the cursor onto this listing arrow. It is next to the snap enabling button. Drop the list of the characteristic names of the characteristic points, and instead of disable software from snapping, indicating the already selected ones, just select, my recommendation, the last snap option in the list, and in this dialog box, clicking on clear all tab, disable software from snapping, and with a click into this box, enable it for indicating tangent points. In applying TTR process, this configuration changing is automatically done. But if the entity is a piece of tangent line, straight line, yes, this is, you see, a must as the first trick. Many will do it. And then say okay, and then, well, I know that tangent point, okay, of the line which is to be created is at the second quadrant of the circle. Move the cursor to its vicinity. After seeing tangent symbol, click, and then yes. Well, the second trick, after saying that tangent to the circle, move the cursor in the sense of the line which is to create. And then, well, here you see along the train the highlighted box ready to gather the length of the line. But the third box, you see there is a number, but we don't know what it is. Well, if it were the case, create a piece of straight line, start the process, then along the train at this stage, we will have a degree symbol within the third box. And also, thanks to keeping the dynamic input button along the status bar as on status, yes, on position, we will have a dotted horizontal line, okay, it is the reference for inclination angles, and a dotted circle arc, okay, extended from dotted horizontal line to the line which is about to be created. And into the third box, we will write the angle. How? After writing the length of the line into the second box, clicking on tab key, we will take a right to write the inclination angle. You know such things quite well. But here, if the line has only one tangent point, okay, well, if the line is in such a characteristic, you see in the screen, although dynamic input button is on, there will be no arc simulation, no horizontal line simulation. And in the third box, you see we have no degree symbol. So, well, be aware, the case is different. Now here, before writing any number into the second box, okay, that box is to input the length of the line. We must say that gonna write the length relative to tangent point. How can teach to the software that it is so? Having add symbol. You know how add symbol is gathered. Clicking on the necessary keys of your keyboard, be able to have add symbol, where you see now a new compartment just created along the train. It precedes the number compartments, and you see within this new compartment we had the necessary symbol, add symbol. Add means the other things are relative. Okay, and then, well, this is of course a tricky thing. You should know. Okay, add symbol is needed. After the second trick, yes, in the order, this is the second trick, can write the length of the line. Well, on the projection, have a look at. Unfortunately, we don't know the length of that line. But in such a case, if the length of line is unknown, then create it with further extension. Make a guess. For instance, write the length of the line as equal to 130 or 200 or even more. Okay, and then if within the following box there were degree and or angle symbol, then I would click on tab key to take a right to write the angle. But here you see there is no degree symbol, so third trick in the order comes to know to deal. Clicked on not comma key, not tab key, clicked on the key of the keyboard on which we have greater than less than symbols. Okay, greater than less than symbols. Well, try to bring a digital. Yes, well, unfortunately in this simulation there is no such a key. Well, you know, well, find the key, okay, in the structure of your keyboard on which we have less than greater than symbols. Clicked on that key. It is the third trick. Clicking on that key, yes, you see managed to have angle and degree symbol within the fourth box. And then the last trick number 4 comes. Into this box, write the inclination angle. But since there is no arc simulation, yes, answer the question. Relative to where and in which direction? Well, here, studying on such a creation issue, it is a piece of straight line, it has only one tangent point. To determine the angle into that box to write as the inclination angle of the line, which is the demanded one, first imagine that as if you have a horizontal line, it passes through the tangent point. Okay, it passes through this point, tangent point. And then say that that horizontal line is the reference, okay, to determine, to measure the inclination angle of the line, inclined line which is to be created. And relative to that horizontal line, it passes through the tangent point. Imagine that horizontal line in the mind, or if it is the case you have hard copy of exam sheet, okay, using your pencil or pen, draw such a horizontal line. It passes through the tangent point. And relative to that horizontal line, well, calculate the inclination angle for the line it is demanded, okay, as measured in the counterclockwise direction. Calculate the inclination angle of the line which is to be created, okay, in the counterclockwise direction relative to that horizontal line. Well, here the 60 degree is the angle for this line, but it is, you see, relative to here, it's a horizontal boundary, and it is, you see, the angle between this and that. But what I am saying, well, into that box, the angle must be written, okay, as the inclination of the line. It has measured relative to horizontal line it passes, not such a one. It passes through the tangent point, and the angle has been determined or measured in the counterclockwise direction. If you do it, yes, here, well, this angle and the angle between this line and the horizontal line which passes through the tangent point, those will be opposite angles. Okay, and from the horizontal line to in the counterclockwise direction to the same line, the angle is 180 plus the opposite angle to this 60. It makes 240 degrees. Okay, I calculated the inclination angle of the line with respect to the horizontal reference. It passes through the tangent point, okay, as measured in the counterclockwise direction. I determine it as equal to 240. Do not write into this box 60, write 240 and then press enter. Thanks God. Yes, knowing this 4 tricks, managed to create such a line. Press escape button. Yes, I hope you understood what I mean. Okay. Here's saying horizontal line, it passes through tangent point. Well, I meant such a line. Yes, it is passing to the tangent, and relative to this line in the counterclockwise direction, calculate the inclination angle of the line which is to be created. And now, well, to be able to create this circle arc, it is a relatively difficult entity to deal. We must know this terminal point, where it is. In answering this question, and also to have the other boundary, here you see there is a horizontal boundary of the projection. I'm going to mark the starting point of this line, this terminal point of the line. You see, well, for this point there is a location dimension. 30 is the location dimension for this point with respect to the center of the already created one. And the other coordinate for this point in the vertical direction is 25. Okay, it is a point to mark. In classical method, you know my technique. I mark the points using transfer lines. Okay, then do it. Start transfer line process, selecting creation process parallel with full distance. And then I know that relative to the vertical transfer line, it passes through the center of the first group of circles. Okay, it is the reference for this terminal point is 30 units. Write 30 into the box, press enter, and then I know that that point is at the right side, so move the cursor to the right and then click. Yes, I am sure this is the line along which to have the terminal point of this line. And then the other transfer line, it is relative to this horizontal transfer line. It passes through the reference point. Indicate and write the coordinate value 25. Press enter, and then I know that point is at a lower level with respect to the center. Move the cursor in the down direction and click. Here we are. This intersection, no doubt, is this terminal point. Okay, then start the line drawing process. Okay, indicate this point as the starting point and then create this line. I don't know its length, but I know that if I create the line with further extension, after trimming, can locate its other terminal point. The other terminal point is this corner point, but I don't know the coordinate of this point. Okay, similarly, I created that tangent line in the order longer than its magnitude. I'm going to do the same thing. Since I don't know the length of the line, I'm going to create it with further extension in this order. For instance, say that as if the length of the line 110 or more. Okay, clicked on tab key. Why tab key? Because you see within the other box I have degree symbol and arc simulation exists. Okay, clicked on tab key and into the box write the angle 180 is the inclination angle relative to the dotted horizontal line. Press escape button. Here is the necessary line, and then, well, without forgetting, start trimming process, and then now trimming the further extensions. Yes, I can have, where is the corner point, and also you see I set the lengths of the tangent line and the horizontal line to their orders. Yes, great. Save the file. And then yes, now for this arc, you know, this is the solution. About point, create a construction circle. About the center of the available one, create the other construction circle. Okay, yes, the size of the one, it is about point P is equal to the size of the demanded one. The size of the other, since the center of the available one is at the outside, uses the sum of the ready. So here, this is point P in construction layer. Yes, select construction option from this list, and then create the necessary circles. Circle option is radius, and then, well, indicate this point as the center for the one of the construction lines. Its size must be equal to 20. 20 is the radius of the demanded one. Okay, yes, this is the locus for all the points being 20 millimeters away from this point. One of them is the center of this arc. For the other construction line, say this is the available circle, already created one, and I know that about the center of the already created one, I need to create a construction circle. Its size must be R1 plus R. Okay, in this example, R1 is the radius of this circle, that circle. The radius of this circle is 20, diameter 40, half of it 20. The radius of the demanded one is 20, so R plus R1, 20 plus 20 is 40. Okay, start circle creation process. About the center of the available one, create the other construction circle. It is radius is R plus R1, in this example 40, press enter. That is it. This is the solution. And then the rest. Well, I am sure this intersection is the center. Start the circle creation process where in visible layer, center radius option is the correct option. System asking the center point. This intersection is the center, and the radius is 20. Great, that is it. You see, circle is perfectly touching to the available circle at only one point. It is tangent, in other words, and it is, you see, passing through the terminal point of this line. Okay, and then trimming. Trim the unnecessary part. I know after this tangent point, the rest is further extension. Okay, after this terminal point, the rest is corner point, the rest is further extension, and then delete the rest, clicking on delete button. Yes, and then yeah, time to apply trimming process for having the hidden circle over there only, because after creating this tangent line and that tangent circle, I know that from tangent point to the following tangent point, this part is needed along this visible circle, but the rest is to be trimmed. Since the hidden circle and visible circle are coinciding, well, while trying to trim the visible one, by mistake I may trim the hidden circle. So, well, I'm going to keep the save the content of hidden layer. How? You know this technique, via locking. Clicked on lock symbol and then lock the layer in which I have hidden lines. So, well, thereafter apply trimming process. Well, if a layer has been locked, then editing process won't be applicable. For instance, trimming will not be applied onto the content of such a locked layer. So I'm using this technique, okay, to prevent myself from deleting hidden line. Started trimming process, and then, well, how can trim in such a case? With a little window, take the part into the area and then click your mouse. Okay, this part, that part, be careful, do not trim the construction line. Or instead of indicating many times the further extension of the circle, if you have lots of intersections along the further extension, then can do what? Either trim the first and the last parts, last segments, okay, or turn the length of the layers in which we have such division lines, which one you like. Press escape button, and here I see that I forgot to delete this part, so I'm going to delete it. How? Using windowing select and push delete button. And then after that tricky trimming stage, well, don't forget to unlock the layer. Otherwise, when you move the projection to a different place, well, you're going to see that hidden circle couldn't be moved. You know, move process is cut paste. These are editing processes. Well, editing processes are all not applicable on the content of a locked layer. So unlock the layer, okay, thereafter you can apply editing process. What? Cut paste. I need to move this projection from its existing place to a new one because I see that it is not at the center. I finished the actually drafting stage. No need to keep this picture in the screen, shoot it, and then, well, using cut paste, bring it to the correct location. At the pasting stage, to be able to prevent software from snapping my cursor, I'm going to so I'm going to toggle off snap enabling button and then start the cut paste process. I selected all, clicked on cut, and then paste, and then make such trials. If necessary, zoom out or zoom in. Well, move the cursor, make such trials to where if I bring the projection to that location, it is going to be sufficiently balanced on the paper. So if you can say that it is sufficient, click your mouse. That is it. And then the good practice, you know, turn the lamps of the layers in which you have transfer lines, you have construction lines. You know how. Turning lamps off, hide them, take their visibilities from the screen, but never delete them. Turn the lamp of construction layer, turn the lamp of transfer line layer. Have the projection only. Here it is. Perfect. Yes, that is the classical method, and you know, in classical method the difficulty is, I said, without drawing this construction and that construction line, impossible to create this circle arc. It has only one tangent point, and creating this straight line, you know, we have 4 tricks: tangency configuration, add symbol, and then clicking on angle key, and then writing the inclination angle relative to a line it passes through the tangent point as measured in the counterclockwise direction. These are the tricky things to know. In classical method, yes, since we have such difficulties or tricks, and well, without drawing construction lines, can say that if you ask me, yeah hocam, for this projection, for such a geometry, which method is more practical? Well, especially the number of entities on the projection to draw is not too much. Okay, on such a geometry, can certainly say that modern method is easier to apply. Next video record, my dear students, you're going to see that it is true. Okay. Well, here I am ending this classwork. The next video record, you're going to see the same example, same projection, but I'm going to apply modern method. And you're going to see that on such a geometry, really modern method is easier, more practical to apply. Okay, finish this classwork. Bye bye. Stay healthy, my dear students. Stopping.